Hello everybody, we're doing our presentation on pseudocode. My name is Jared Beagley.
I'm Adam Quinton.
I'm Sam Barlow.
Next slide. So as an explanation for what pseudocode is, we found a couple of different good definitions and explanations of when to use pseudocode, but one of the best was an article that said, when writing software, programmers will reach a point when the class structure has been designed and the major routines inside each class have been defined, but no code has been written yet. Taking the next step, writing the routines from scratch in an elegant, efficient, and maintainable way is a nearly impossible task without a systematic approach. And so, in other words, you're taking the code, you're taking the designs that you have, and you're going to turn them into the one step behind actually coding them. And so it's the process, pseudocode is the process of taking the designed classes and methods and representing them using a more basic language instead of the actual code. This helps you to design exactly how you're going to write the code and be able to give yourself a step to go down on once you've gone through the entire design, and gives you a good place to be able to find bugs and defects instead of actually having the code already written and finding them there. Next slide.
So according to Noah Dorsing in his article titled Pseudocode Programming Processes, there are two types of pseudocode. There's good pseudocode and there's bad pseudocode. Next slide. So bad pseudocode. Some examples or some attributes that bad pseudocode carries is that it's superfluous, low level, and detailed. And terms of a certain programming language like C will be used, such as malloc and struct all throughout the pseudocode. So it almost looks like code, but you want to get as far away from that as possible. You want to have it be able to be implemented in any language. Next slide. So good pseudocode avoids code-like statements or anything to do with differences in languages. So we can bridge the gap across any language and still write this into actual code. It describes what and not exactly how. And notice the word exactly. It does describe how. It just doesn't describe exactly how. So it should be low level enough to almost automatically code, but it should still not describe exactly how. Next slide. So here we have some examples of good and bad pseudocode. So on the left is bad pseudocode. You can see that the term malloc, which is something in C, is being used, and null and return. Those aren't always bad. You could use return. I guess it's just up to you. But let's just focus on the good pseudocode. So the good pseudocode on the right, all that could have been done in one line. Create an empty list of unsorted tasks. It doesn't say what to name the variable exactly. It doesn't say what type of data type to put the variable in, although some of those things could be included. Next slide. So a real-world example or analogy is when a child learns to ride a bike. They normally start with a tricycle or something with four wheels. The tricycle that they're learning to ride is not a bike and has many differences, but some of the things that they're already doing, like learning to rotate their feet or to steer, are going to be the same when they use a real bicycle. Just like pseudocode. Pseudocode doesn't teach you everything about how to write code and doesn't exactly say what to do, but it does provide instructions that are core principles that are going to remain in the real code that is written. Next slide.
So an example for our project would be our displayed assignments or tasks. For example, there's several different ways that you can sort an assignment or task list on HATA or on our application. And so the way that you would be able to do this using pseudocode is, let's say you wanted to take the tasks and sort them by the date that they're due. And for this example, we'll use the bubble sort pattern. You take a list of the sorted tasks, and as you can see here in the pseudocode, that you took the list, you just defined it, you didn't actually write the list and then the name of the variable. You just say you need a list of unsorted tasks. Then you take that, and instead of writing out the while loop, you just say until the sort is completed. and then loop through one less than the size of the unsorted tasks. And if the sorted task's due date is later than the next unsorted task in the line, then swap the tasks. And if no tasks are done in the loop, then the sort is complete. You'll notice here with this pseudocode, this may not be perfect, but it takes it at a more high level than the actual code written. But it is still pretty easy to take this code, this pseudocode, and turn it into actual applicable code for what we're doing. And you'd be able to take the same concepts and pass them over into knowing exactly how you wanted to format your different loops, your different checks that you're going to be doing on this. And that's one of the main benefits here. If there would have been a problem with the logic or with what we were trying to check, we would have been able to probably identify it within the pseudocode itself here. Next slide. Another example in our web app would be, or in our mobile application, would be the alerts that we send out each day for what the tasks are going to be due during the time that the user is specified. You'd have to do some sort of check to see which ones we're going to send out. And so in this example, you have just a list of all the assignments and a list of assignments that are going to be alerted there. And so you loop through all the assignments, and then if the due date is within the notification time span, then add that assignment to the list of assignments for the alert. Again, we're not using any actual programming words here. We're just saying exactly what you would need in human readable text. Next slide.
So now we want to talk a little bit about the upsides of pseudocode, and then talk about the downsides, and talk about our recommendations for how pseudocode should be used. So, the upsides start off with a quote: "The field of parallel computing is rapidly advancing, and hence no single model or programming language has been widely accepted. For this reason, we have chosen to use pseudocode." In other words, one of the advantages of pseudocode is that no specific syntax is necessary. Pseudocode applies to every programming language and every method of creating applications, regardless of the syntax or what goes into that language. Another advantage is that pseudocode has inherent longevity. No matter what happens to computer programming or what the future holds for us as programmers, pseudocode will be applicable and convertible to any language. Another upside to pseudocode is it's easily modified. It's easy to write, and it's easy to understand, even if you have a limited background in programming or if you have a very deep background in programming. Next slide. There are some downsides to pseudocode as well. Pseudocode has been shown to be less useful for more complex algorithms than similar methods such as flowcharts. A man named D.A. Scanlon wrote up a report on a study he conducted where he compared the effectiveness among students of pseudocode versus flowcharts. He says, quote, "My experiment shows that the more complex the algorithm, the more beneficial structured flowcharts are. I computed ratios that compare pseudocode to flowcharts for the amount of time subjects spent looking at algorithms. The ratios favored flowcharts across all three levels of complexity." So, the more complex a topic or a code is, the less useful pseudocode is. Another downside to pseudocode is that it contains no visuals and that it is not standardized. There's no accepted method of pseudocode, and different people could have very different pseudocode for the same concept. Next slide. In conclusion, we recommend pseudocode for situations where you need to express more simple code in a way that's easy to write and understand. And we recommend that if you have a very complex code concept, you use another method of expressing it in a more easily understood way. And if your code would benefit from being expressed visually, then another method would also be better because pseudocode has no visual aspect. Next slide. These are our sources for our presentation, and thank you for watching.